Hi, in this next video we're going to look at how to solve equations involving e and involving natural log. So these first ones we're going to look at involve e. Now there's two helpful little properties that I can show you using the laws of logs, where they come from. If you have a log of an e to the x, then this is just e to the x. Okay, and just to show you why, if I use law 3 on this, I can bring the x down to the front. And I already said on the previous slide that that's log to base e of e. This is just 1, which means that x equals x. So if that's true, then that must be true. Okay, so that's a helpful little thing. Likewise, e to the log of x equals x. Well, this is in base power equals answer form. So if I write that as log to base e of x equals the power, then log x equals log x, which is true, which means that must be true. So those two little helpful rules are true. Doesn't have to just be x. If you've got log to base e of 4a minus 2, then that's going to be equal to 4a minus 2. So whatever the index is there will be there. All right. Now the reason why I've mentioned that is because these two things quite often crop up when you are solving equations involving e and natural log. Okay, now general rule. If you're solving an equation involving e, that's in exponential form, so ultimately you're going to have to go to log form. And because we are using e, then we are going to use natural log. When you are solving equations involving natural log, then ultimately you're going to end up writing it in in exponential form, and we're going to use e. So because we are moving backwards and forwards from exponential to log form and we're using e, then we're going to use natural log. We are not going to use any other base. So don't use log to base 10. We're going to use log to base e. Okay, so there's three different types of questions here, slightly different approaches. Okay, so you've solved equations involving exponentials before. Sometimes you might have to write it in log form. You've got disguised quadratics, and sometimes you have to take logs. So those are the different approaches, and that's what we're going to do for each one. This first question, you should be noticing that that is in base power equals answer form. So if it's in base power equals answer form, we are going to go to log form. So we're going to write that. So we're going to go into log form, log BAP. So we're going to write it as log to base e. Now if it helps, just to get it in the right form, write it out fully first. Log to base e of 4 equals 2x plus 1. Okay, so if you need to physically see the log BAP, then feel free to write it out. Okay, but ultimately we need to be using natural log. And then we're just going to make x a subject. So if I take one off, so 2x is going to be, I'm just going to write it as negative 1 plus log 4, because log of 4 minus 1 looks a bit like the minus 1 might be logged. So I'm just going to put the minus 1 at the front. And then we need to divide by 2. Okay, now we're nearly there, apart from we've got a log 4. Can we simplify that log? Well, 4 is 2 squared, so yes we can. Minus 1 plus log of 2 squared, bring the 2 down. That's going to be 2 log 2. Okay, so we can either leave it like that, or we could split the denominator up and say it's negative 1 over 2. 2 log 2 over 2 is just log 2. So either we need to leave it like that, or we need to leave it like that. Okay, but we need to make sure if we'd have left it like that and stopped there, we would have got penalised because of that. Okay, so that's the first variety. All right, so you need to spot if it's in that form. Okay, this next one, I'll do in purple. E to the x plus 8 e to the minus x equals 9. Okay, if you have an equation where you have a negative index, the first thing you should do is rewrite it so that it has a positive index. So instead of that, it's going to be e to the x plus 8. That's the same as 1 over e to the positive x, or 8 over e to the x equals 9. Okay, now we've got an equation with something on the bottom. We're going to times by e to the x. Whoops. E to the x times e to the x is e to the 2x plus 8 equals 9e to the x. Okay, now this is now a disguised quadratic because you've got an index that's double the other one. So if I move that 9e to the x over, hopefully it looks a bit more recognisable. Okay, so let y equal e to the x. So we've got y squared minus 9y plus 8 equals 0. Y minus 8, y minus 1. So y is 8 or y is 1. Put x back in, e to the x equals 8, e to the x equals 1. And now, because this is in base power equals answer form, base power equals answer, we're going to go into log form. So it's going to be log to base e of 8 equals x. Log to base e of 1 equals x. This one, well, 8 is 2 cubed. So x is going to be log of 2 cubed, which is 3 log 2. This one, log to base anything of 1 is 0. So 2 solutions, 3 log 2 and 0. And then this last one, well, this one's a bit trickier because we've got a base 2 and a base e and a number. So it's not in this form. So we need to do a different approach. What we're going to do is we're going to take logs. So we're going to take logs because we are using e, then we are going to apply log to base e. So we're going to take logs by saying it's log of the thing on the left. That's got to be considered as one whole thing. You can't stick a log in front of that and in front of that. Just log of all of that equals log of that. This is now a product. So we can separate that using law 1. Log 2 to the x plus log e to the x equals log 3. This one, I'm going to bring the x down to the front. This one, well, this is now this thing here. So log e cancels itself out, and this thing here is just an x. which is quite nice. So that's what I mean by this thing quite often happens if you end up taking a log of an e. Just need to make x the subject. So if I factorise, and then divide by that log 2 plus 1, I'll get log 3 over log 2 plus 1. This is in its simplest form, so is this, so the whole thing is, and that's it. Okay, so if you have something a bit funny like that, or if there was an e with an index equals an e to another index, or some other base to another index, then you would have to take logs. Okay, you could have taken logs here on this one as well, don't forget. Solving equations involving natural logs. So those ones all involved e and required logs. These all involve logs. So the following leaving answers in exact form and as simply as possible. So if need be, we're going to leave it in terms of a log as simply as we can. Now just to remind you, when we are solving equations involving logs, we are looking to get two possible scenarios. Either we're going to be getting something in that form. So as soon as we've got something in this form, then we can go to exponential form. Alternatively, we need to try and get something in that form where we can drop the log, sorry. If this is true, then we can drop the logs off and just equate the two things. Okay, so we've got either we're going to try and work it so that we end up with something like that, or we're going to try and work it so that we end up with something like that. Okay, so let's look at this first one. So we've got three terms, two involve logs. So let's bring the logs together first. So let's take off that log. So we're just going to collect up the logs. So this is log 2, log of something take log of something else. So we can write that as log of 5x plus 1 over x. This is now in log back form, log to base e of the answer equals 2. So we're now going to go, so this is in log back form. We're now going to go into exponential form. So log to base e, so e to the 2 equals 5x plus 1 over x. Just need to rearrange it. Remember, we're not going to do anything with that. If I times by x to get it off the bottom, x equals, no it doesn't, e squared x equals 5x plus 1. I'm just going to come up here, take off the x. I'm just going to gather up the terms with the x. So if I take 5x off, because I want x to appear once, so I need to gather these together in order to factorise. And then I can divide. Okay, so if you have lots of terms, but one of them, two of them isn't a log, then you're gathering the logs together use the laws to combine the logs so that you've got it in log BAP form, and then you are going to go into exponential form. So that's the first one. Second one, 3 terms, each of them have got a log in it. So for this one, I'm going to end up with log of something equals log of something else. That's what I'm going to do. So I'm going to leave that one there and combine these. In order to combine these, I can't have that 2 there. So the first thing I need to do is raise that using the law 3. Okay, and I'm also going to raise that and say that's log of 2 cubed. Now I can use the law 2. I've got subtraction. So log of x plus 2 squared over x equals log 8. Now we've got a log of something equals a log of something else. These two things must be equal to each other. So x plus 2 squared over x equals 8. And essentially now we've just got a quadratic. So times by x, x plus 2 squared equals 8x. Now I'm just going to expand that out. X squared plus 4x plus 4 equals 8x. X squared minus 4x plus 4 equals 0. So just trying to solve that quadratic. So it's going to be x minus 2, which means x equals 2. And that's the answer. Okay, and then this last one, log of x all squared equals 6 log x minus 5. Now I've put this in just because it's very common to write that as 2 log x. Okay, you cannot bring that power down. Log x squared. So if it was a log of an x squared, then those two are the same. Okay, but this is not log of an x squared, this is log x all squared, so it's different. What we have here is a square term, a letter term, and a number term. So what we have here is a disguised quadratic. So I'm going to move everything over to begin with. Take 6 log x plus 5 equals 0. So let's let y equal log x. Y squared minus 6y plus 5 equals 0. Let's factorise. Y minus 5, y minus 1 equals 0, y equals 5, or y equals 1, which means log x equals 5, or log x equals 1. Now we can just write that into e form. This is in log form, log to base e of x equals 5, which means x equals e to the 5. Log to base e of x equals 1, that means x equals e to the 1, or just e, and that's that. Okay, so please don't, when you're thinking about your laws of logs, this is not applicable for that law. Okay, then the next video we are going to look at some more contextual questions that involve, so it's bringing everything together. It involves finding the rate, and also will involve solving some equations. Okay, so that's the end of the fourth video.